Hello and welcome everyone. My name is Mark Henry. I am a senior engineer with Opmantek's North American office located in Charlotte, North Carolina. Today we're going to be talking about event escalation and notifications in NMISS8 and in opEvents. A little bit of light housekeeping for everyone today. All of our attendees are on mute during the presentation. We do have a full house today, a lot of people in the background, so we're going to keep you all on mute during the presentation. However, we do want to encourage questions, so please use the GoToWebinar's chat window to send questions along. I do have a couple of assistants who are keeping track of that. We'll help queue them up for me, and we'll try to get those answered during the presentation. We will have a Q&A session at the end of the webinar, so if you want to hold your question till then, you can do that as well. That's fine. As a reminder to everybody, the session is being recorded, and what we'll do is when we get to the end of the webinar, we'll stop the recording, open the floor up for the Q&A questions. We can have a bit of back and forth banter if you want to. That's absolutely fine. So topics for today. We're going to talk about NMIS8's thresholding system. That's the system of performance alarm points that actually generate events. We're then going to talk about how you can use NMIS8 and the escalation policy system in there to build out rules for monitoring and alerting people based on those performance data exceeding the thresholds. We're going to talk about how to expand on the pre-built notification system. And then we're going to dive into opEvents and see how opEvents complements and expands on NMISS's escalation policy and rules. So a lot of data to cover, a lot of ground rather, and let's get right into it. So all of Opmantek's products try to follow the ITIL and ITSM process standards. Looking at the situation from an ITSM maturity model standpoint, when you're looking at processing events, really what you're doing is you're dealing with problem management, alert and event management, component availability, up and down time, you're setting thresholds, you're predicting problems, and that all helps move you from a kind of a level 0 or 1 point where many of our prospects are when we first start engaging with them, and move them solidly into a 1 to 2 and start getting them the groundwork to move into a level 3. The whole concept here in moving you up through the management maturity model is to increase the performance of your network and of the services and of your staff, and also, of course, improve the value to the organization. So today we're really going to be focusing on two of Opmantek's solutions. The first of which is the free and open source NMIS, which is the core performance and fault monitoring system. It has all of your device databases, backends, all of your polling metrics, all of your polling requirements, all of those settings are done in NMIS. You can see in the big wheel on the right-hand side, NMIS is that core, that circle in the center hub of that wheel inside the green. And then we're also going to talk about one of Opmantek's commercial solutions, which is opEvents, which adds an intelligent event response and also expands on the event escalation and notification system dramatically. So NMIS8 thresholding. We can't really talk about event notifications until we understand how events are created. And the thresholding system in NMIS is one of two methods that can create events inside NMIS. So the first one is really what we call stateful events, which is the concept of a two-position light switch. So either a device is up or it's down. Stateful events are self-clearing. So if NMIS loses connectivity with a device, it might mark that device as down. And when connectivity to that device comes back and NMIS can pull it and get communication with it, that device's state would then come back up again. So it would go node down and then node up. So two different events, and they're stateful. They cancel each other out. Thresholding, however, is the concept of having one or more alarm points that performance data trips over, and those could be rising or falling alarms. So for example, temperature. You might look at a normal range of temperature on a device, and as the temperature sensor reports back in the device's temperature, you might have multiple levels of threshold as the device reports back a high temperature, a critical temperature, and a fatal temperature to you. You may have various levels of thresholds in there, where as that temperature is rising, those thresholds are being exceeded, and that's generating an alarm, and something can happen there. NMISS comes pre-built with 6 different threshold levels that are defined in the system. That is normal, so it is the normal operating window for that specific parameter on that specific manufacturer and model of device, followed by a warning, which is the first level of something being out of the acceptable normal window, followed by minor, major, critical, and finally fatal. NMIS comes pre-configured with threshold levels predefined based on type of event, type of model, manufacturer, and even down to the operating system on the device. So those are pre-built. They're based on both industry standards and also manufacturer recommendations. You can, of course, move those around. You can remove different levels. So if you don't care about warning, minor, or major, you can either ignore those, or you can actually remove those alarms completely so they never generate. Completely up to you. You can adjust the system all you want. Our recommendation from an engineering standpoint is to get the system up and running, add devices to NMISS, and then see the types of data that it collects and how the thresholds work for you. And then once you're actually familiar with it and you're comfortable with it, make adjustments at that point. Events are normalized across similar OIDs and manufacturers. And what I mean by that is that a CPU, say high CPU high usage on one manufacturer will be mapped to the same alarm settings as perhaps another server manufacturer. So an HP server versus a Dell server. Those CPU high usage alarms would be mapped to a common or normalized storage point. So to set up, to get access to those, that's all just going through setup, then threshold alert tuning in the NMISS menu. And we're going to open that up in a minute. We'll talk about that briefly. The thresholds themselves, you can access them all through the NMISS GUI. So there is again, through setup, threshold alert tuning, you can get access to a GUI implementation of that. And it's also stored in an actual configuration file called common-threshold.nmis, which is part of the NMISS modeling system. So taking just a quick look at what that looks like from the GUI standpoint. So over on the left side, you'll see that we have different OIDs that are being mapped in into different storage areas. So specific, in this case, I believe it's looks like router OIDs that are being mapped into specific attributes with specific names. And then over on the right-hand side, we actually have those attributes then having thresholds assigned to them. So you can see that in the bottom right-hand corner down here. We also have some control aspects here where we're saying we're only going to apply these to devices with a role type of core. And so you can actually define things like distribution core, edge, etc., and then use those role types to help drive different types of alarm periods. So again, 2 different ways that NMISS generates events. One is through stateful type events, node up, node down, SNMP up, SNMP down, etc. And then through the thresholding system. And again, those can be rising or falling thresholds. So once an event is created, is generated in NMISS, NMISS then writes that event out to the NMISS event log and then begins processing those events. So how are those events processed? And there are really 4 big steps. You create a series of contacts, so people or things that can be notified. You assign some escalation policies. You can test the notification, and then you can adjust the configuration. NMISS starts the concept of notification with the idea of creating escalation periods. So escalation periods are the concept that once an event happens, a timer starts in the background and things happen as time passes and that event stays active. So as long as that event condition, that threshold, say the temperature sensor stays high and a warning is being issued, as long as that event is still open and the temperature is high, time will continue to pass and things can continue to happen at various time points. NMISS has one defined escalation period process. It's defined under system configuration, NMISS configuration. Then you select the escalation and you can define these. This is across the board for all events. So for example, from the window on the right-hand side, you can see that escalate 0 is set to time 0 or 0 seconds. Some people call that time 0 from when the event occurs. And then each of these windows, 300 seconds, 900 seconds, 1800 seconds, 2400 seconds. Something can happen at these windows. So for example, if you're watching a node down, escalate 0 would be at the moment that the node down event occurred. You might write out to a syslog. Escalate 1, which is at time 5 minutes. If the event is still open, if the event hasn't self-cleared, or if someone has not acknowledged the event in NMISS, then you could do something else. You might generate an email to the on-call help desk technician. At escalate 2, you might do nothing. You might wait until escalate 3 at time 1800 seconds and generate an email to the NOC center manager, for example. You might also generate an SMS text message to the help desk team, etc. Lots of different things that you can do, and we'll talk about what happens. Generally speaking, from a kind of best practices standpoint, any kind of notification to a human should go to a human that can actually take response. Generally speaking, we recommend that escalations to humans only happen after a second polling cycle for that device. So starting in the most recent version of NMIS, which is 8.6.4G, we now have variable polling cycles. So you can create custom polling windows. So you might be collecting on some servers once every hour, on your core network equipment every 5 minutes, and on critical devices once every minute. But when an event occurs on a device, you should wait until at least the second polling cycle, so you make sure that it wasn't a kind of a collection issue off the device, a burp across the network, etc., and that the event is still active at that second polling cycle, and then start notifying humans to take action. Again, that's kind of a workflow recommendation, not a system process inhibition. You can notify humans if you want to right on escalate 0, right at the moment that the event occurs. So again, these come pre-configured with the numbers that you see in the panel on the right-hand side. We recommend strongly, again, that you set the system up, you get it working, you add in some basic escalations and notifications, see how that works for your team, and then only adjust these after you've had a period of time to evaluate how these notifications work and how they're working for your team, and then have a team discussion about it and kind of assign, who gets notified when, why, etc. So once you've created these escalation periods, the next piece is to actually create contacts inside NMIS. Now there are many ways to notify people and things. You can write out to syslogs, you can push syslogs to other devices, you can create SMS text messages, you can do pager alerts. There's all kinds of things you can do, but everything starts with a contact. So if you're gonna push an SMS text message, you have to have a contact with a mobile number. If you're gonna push out a pager alert, you have to have a contact with a pager number. If you're gonna push, say, a phone call to a third-party service that might receive an email and phone someone and then read the content of the email, you've got to have a phone number for, as part of that package to be sent to that kind of a service. Contacts also have things called duty times. So when does this contact work? Duty times, duty days, even time zone, all default to the local server unless the time zone field is set. So if you set the time zone field for the contact, it will use the time, duty time, and dates for that time zone. It'll actually do the conversion for you. Otherwise, duty time is the start and stop time in hours. So those are whole hours. In the example, you see 06:20. So that's 0600 or 6 a.m. to 2000 or 8 p.m. Monday, Tuesday, Wednesday, Thursday, and Friday. Of course, you can expand that to Saturday and Sunday if you wanted. Next, you have the days of the week lined out. What days does this contact work? What level of events, what priority level do you want this individual to get? Do you want them to get fatal, critical, major, minor, warning, and normal? So you can delete those, right? That is a vertical pipe in between each of those. So between fatal and critical, that's the vertical pipe, which on the US keyboard is on the / key, which is right above the right-hand enter key. You'll have the email for the individual. You can put in their location, and that needs to, or that should resolve to an NMISS location, to the name of an NMISS location. Then you can include their mobile number, page number, and phone number, of course. Any piece that's blank will cause that notification method to fail. So if you want to send a pager alert to contact 1 and there's no pager number, that will obviously fail because there's no number for you to use. You can enter these through the NMISS GUI. That's also available, of course. It's stored in the contacts.nmis file, so you can see those in plain language. One note, and I'll mention this again later on when we start talking about opEvents. opEvents has its own contacts.nmis file for keeping track of contacts. Generally, when you do an install of opEvents, it will actually create a symlink rather than create a blank file for you. So it'll create a symlink from the omk/conf/contacts.nmis to the NMIS8 conf/contacts.nmis file. You can, of course, break that symlink if you want and create a separate contacts.nmis file if you'd prefer. So we have escalation periods, we have contacts. So now we talk about escalation policies. So the concept here is straightforward. What you're looking to do is you're looking to match a set of criteria, and the criteria that's listed here are all considered ands. So group and role and type and event node and event element. All those things have to match in order for this rule to execute. Once this rule executes, then the escalation time periods begin. So these level 0, level 1, level 2, this is escalate 0, escalate 1, escalate 2. So these refer back to those time periods that we talked about a moment ago. And then these are simply the commands that execute. A command is separated by a colon. So net send colon workstation 1 colon workstation 2. It's going to create a net send to those two workstations, comma, email contact 1. So two different things. You're doing a net send and an email at time 0, and then at time 1 or level 1 or escalate 1, there's going to do a pager to syscontact, comma, email colon contact 2. Notice level 2 has no example in it. And then at level 3, they're going to do an email to contact 3 and contact 4. We strongly recommend you don't use names like contact 1, contact 2, contact 3. Then instead you use things that are more human readable and mean something. So when you create your contacts, you might do NOC manager, operations manager, CTO, on-call weekend, on-call nights, etc. There are several different built-in notification methods. There are 6 of them in all. We've listed them here on the screen, and this presentation is available in a PDF format, by the way. If you didn't hear me mention it earlier, if you look on the handouts pane in the Go to Webinar window, you can download that as a PDF, right, to follow along. You can also get it off of our website in the blog section after today's section. That should be posted sometime tomorrow. But NMISS comes pre-built with syslog, JSON, email. You can do carbon copies, so you can actually push the event to other systems. You can do pager, and you can do net send. We'll talk in a minute. You can also expand this system. You can build additional notification methods. Before we get into that, what I'd like to do is I'm going to switch over to NMIS, and we're going to just put together an example, couple one of these escalation policies just to see how they work. So I have NMISS864G open on my demo server. I'm just going to close a couple of panes here. Setup, emails, notifications, and escalations. So I'm going to open that. We ship with just these 4 example pieces built in. You can delete these, you can edit them, whatever makes the most sense to you. But let's just take a look at one of these. So for example, in this piece, what we've said is for any group, and the word default is read as any. So where it says group default, that means any group. So a device in any group with the role of access, a type of default, again, meaning any, for any event. So any device with a role of access. So you might have your routers and switches, you might have some firewalls, all defined as being access devices, as type access. So this is going to capture everything, every type of event, every type of device that's been assigned to a role of access. And what happens in this one is at level 1, again at escalate 1, it's going to email contact 1, and then at level 4 or escalate 4, it's going to email contact 1 again. The last thing I want to point out is this up notify. Up notify is when the event clears. So again, if you have a stateful event, node down, node up, when it'll generate an email to know on the down event, and then when the device comes back up, it'll generate another email because up notify has been set to true. So you can actually control quite easily whether this sends out a notification that says when the event that's being matched clears. So let's create a new one of these. So I'm just going to hit add, and what it will automatically do is it'll give me a list of all of my groups, so I can pick a specific group of devices. Right. So for example, I might say all the devices that are assigned to the Charlotte group, and you can be complex, right? So I might say, well, not only all the ones that are in Charlotte, but all the ones that are assigned as core devices. And I can pick types as well. So you have some kind of grand types: router, switch, server, firewall, and generic. So I might say core devices of type router. And I can even pick all of the different types from all of my different events that are available in the system. I can pick a specific event if I want to, or I can simply leave them open. If I want to, I can specify a specific device, an event node, and you simply use the event or the device's name that you want, one device at a time, please. And if you want to get all the way down to an element, so what I mean by an element is an actual physical or logical interface, something that NMISS is tracking. It has to be collected. If NMISS isn't collecting on that element, you'll never get an alarm. Keep in mind that all of these things have to evaluate to true. So if I were to use an event, if I were to put in a device name for a switch, I've already said I want a device that's a core role of type router. So if I had a switch or a server as the device, I would never get a full match on this. This would never fire. So we really recommend that you think through the types of events and alarms that you want to create, who would be notified, and then what action they would take. In many cases, when we're working with teams and helping them integrate and absorb NMIS, the first thing we do is we say, look, let's start with the volume control on events cranked all the way to 11. Let's just generate events and notify people, generate emails on everything. So we might start with this, and we might simply remove most of these. And if you remember, escalation level 1 is at 5 minutes. I might simply say email ops team. And of course, I would have created a contact called ops team. And I do it at level 1, so that's 5 minutes. So level 0 is at time 0, or when the event occurs. I wait 5 minutes. If I'm using my default polling cycle of every 5 minutes, then a second poll would happen, and then I'd have a little more data when this is evaluated, And if this event is still good, I would generate an email to the ops team. So we recommend you start very noisy on your emails, and you can send them to a email address that is kind of a throwaway, is something that you're going to use for evaluation, for setting up and getting NMISS configured and seeing how it works. See how noisy the system is, and then start making lists of events that you want someone to respond to. So you start evaluating the events that are being generated, and then you can start determining which ones you want to do something about. Now, the mistake that many people make at this point is, rather than turning off the notification, turning off the email for that event, instead what they do is they turn off the threshold. So they don't generate the event to begin with. That can be kind of a false path. You want NMISS to run the thresholds, collect the performance data, run the thresholds, generate the events, and then once you have the events, you have data, then you start determining how you're going to take action against those events. If you don't collect the data to begin with, then you can't determine what to do in the future, right? So you can always turn the escalations or the notifications back on later, but if you're not collecting the event anymore, if you're not setting your thresholds, if you're not generating events from that thresholded data, then you have nothing to build off from at that point. You also don't have data to make important decisions moving forward on how your group should troubleshoot and repair and optimize the network to get the best performance out of it. So you have to understand what's happening across your network. It has to start noisy and then turn the dial down, as opposed to starting quiet and turning the dial up. So I mentioned that there are 6 built-in notification methods. So you can do syslog. So you can actually write out to the local syslog. You can write out to a local or remote JSON file as well. So you can write events out to those. You can generate an email. You can do a carbon copy, which is a type of email notification as well. You can do a pager, and you can do a net send. So those are the 6 pieces that are built in with NMISS as it ships. We do have a handful of additional ways that you can expand on this system. So let's switch back over to PowerPoint. And let's talk about how to expand out of those 6 pieces. So those 6 built-in notification methods that are there, the first thing that I often hear is, well, can I do SMS text messaging? And the answer is absolutely yes. Simply sign up for a business SMS service, get the information on their API, and then create a notification method that calls that API. And we'll show you an example of that in a minute. This is all done in Perl. All of your notification methods are written out in Perl. Again, we ship with several examples from you or for you to work with. Those Perl scripts, these little stubs, are called methods. Those methods have access to things like the contact's details. So they have access to the contact name, duty time, email, location, mobile number, pager number, phone, and time zone. The notification system also has access to the NMISS event details. So you'll have access to the acknowledged state. So has the event been acknowledged? You'll have access to the event details, the elements, the escalation level, the priority level or level of the event, the node name, the device name, the time the event occurred, and if someone needs to be notified. So notifications are all stored in this subdirectory, NMISS8/lib/notify. And at the bottom of the screen, and again, a copy of this presentation is available in PDF format in the handouts window. That link at the bottom of the screen will get you to the wiki page with the full write-up on this method. But let's take a look at one of these look like. I'm just going to open up an editor here. So this is BBEdit. It's my preferred editor on the Mac. If you're not familiar with BBEdit, I recommend you take a look at it. It's a very good all-purpose editor that does color coding, line numbering, does diffs, compares, all kinds of stuff. It's lightweight, and I think the last time I bought a copy was around $15. So it's very, very affordable on a per developer basis. Don't let the fact that this is all written in Perl kind of overwhelm you. It's a pretty straightforward scripting language. We do ship with, again, 4 or 5 different examples built in. My recommendation is you open up this first one called critical.pm and take a look at that. The example on the wiki page has you open up one that writes out to a syslog, and that's nice if that's kind of the function direction you want to go. But what we hear most people want to do is that they want to execute some kind of a third-party API, or they simply want to do some kind of a customized email beyond the stock email template that NMIS has. So the big pieces of this are adjusting your package name. So take critical.pm, copy it into something else. You might copy it to SMS message.pm and change this piece, critical, to be the same name as the file. So if you name it monkey, this would be notify : monkey. Everything at the top above where it says sub send notification, you can pretty much ignore. This section is grabbing the arguments, the pieces that are coming in from contacts and from the event, and storing them in variables that can be used locally. Again, look at several of the examples of these notifications and see what different pieces are stored. Then in this example, we're going to be generating an email. So we start building some things. We start capturing things like the contact's email address, the contact's mobile number, and storing it in local variables that we can then reference easily. There happens to be a comparison here. So we're saying only do critical.pm if the nature of the events meet certain criteria. This is completely up to you. It's optional. You don't have to have this match in here at all. It's here as an example, again, of things that you can do. So for example, in this case, we're looking to see if the event is an interface up or down, and the event details contain the word critical. So if those two things match, then we're going to generate an outbound email. You'll see that we're outputting to standard error window as well. This way, there's all kinds of cool debugging that can go on. So if debug is enabled, we're going to write out to standard error. So you'll have some data on what's going on with this. You can debug this a little bit. And then this whole piece is simply calling an internal function called send email. That's actually an NMIS function. It's a function that's exposed to the all the internal pieces. We're calling that internal function. We're passing it things like the sender, the recipients, the mail server, server port, the domain, TLS, etc., username, password, who it's going to, who it's coming from, subject line, the body, and the priority. So you'll notice because we're defining the body here, you can actually make this say exactly whatever you want it to say. And then at the very end, we're waiting on a status, a reply status from that service call. And then we're responding to it. We're writing out a few more print debug pieces that are here, and that's it. At the very bottom, you'll see that there's an example of what the data from the contacts look like. So you have all of the different fields from contacts, so you know what to refer to, and also from a sample event. So you can see all the different pieces that are available to you as well. So lots of different pieces that you can do here. Another example, we ship with an example of an SMS text message. So same thing, this one happens to be called sms.pm. So you'll notify that this is, or you'll notice that this is package notify : SMS. So that matches the file name less the extension. If I scroll down to the send notification, we're capturing certain arguments. In this case, we're capturing the contact, the event, and the message to be sent. Now the sample contact and event just happens to be up in the top of this file. In this example, we're checking the level of the event or the priority of the event. In this case, is it major, critical, or fatal? So for any of these levels, then we'll generate an SMS text message. We're building the message string. And again, lots of things that you can do here, right? We're creating the message string by adding the SMS time to the message string itself, figuring out who it's going to go to, who it's coming from, and then we're calling a web app. So this service unfortunately no longer exists. This company's closed down business, but again, it's an example of how to call an external web application. There are many different types of web services that offer different types of SMS text messaging, even live text-to-speech phone calls. Companies like PagerDuty come to mind, etc. But there are dozens of them. So you would have to talk to, find an online service that'll handle that for you, understand what their API is, how you can call it, and how you can pass information to it, what parameters would be required, and then what you would get back from that. So do you get, what do you get back from it? And then do whatever kinds of log handling you might want to have for your example. Again, this is just a kind of a down and dirty, walking you through some of the examples that ship with the system. When it comes to notifications, really with any kind of programming or scripting piece, it's writing down the steps that you would need to take yourself if you were going to take the action, and then understanding how you would script through those. If you have an NMISS support and maintenance contract and you want to build out a notification, work on it on your own, see where you can get. If you're running into problems, email support@opmantek.com. We'll be happy to help you out. If you don't have a support and maintenance contract, you can email usa@opmantek.com, and one of our account managers will be happy to talk to you about a support and maintenance contract, or even just a kind of a one-off, how can we help you today type situation. So we can do something on a time and materials billing as well. All right, back over to the PowerPoint. So we talked about the concept of building out NMISS's escalation policy. So the concept that NMISS comes pre-built with 10 escalation levels, starting at time 0 and going out through a 24-hour window. You can, of course, change those out if you want to. There's contacts.nmis, where you actually create all your contacts that you're going to notify. And then building out the escalation policy itself. The idea that you would actually create the rules that will notify people or write out to syslogs, and you can write syslogs out to other machines if you want to as well, or write out JSON files, etc. And then also how you can take those 6 notification levels, syslog, JSON, email, carbon copy, pager, and netsend, and expand on those with NMIS8's notification system to add custom notification methods like SMS text messaging or even custom priority emails. So NMISS's built-in escalation system is very, very powerful on its own. It can be expanded quickly and easily to handle most situations, but there are some key things that NMISS's escalation system does not do that are fulfilled by Opmantek's opEvents commercial module. So opEvents plugs into NMISS. So if you think of NMISS like the center or hub on a wheel, opEvents is like a spoke on the wheel that plugs seamlessly into it. So taking a look here at the screen, you can see that we've got NMISS here in the center, and NMISS is doing service monitoring. It's handling SNMP and WMI polling, and it's also processing SNMP traps. All of those events are normalized inside NMISS and written out to the NMISS event log. That event log is shared to opEvents, and opEvents then reprocesses the NMISS event log and applies whatever rules you have configured in opEvents. opEvents also receives additional inputs by parsing syslogs. So you can point device syslogs to opEvents. opEvents will parse those syslogs. It can create entries, device entries in the opEvents device database for devices that don't exist in NMISS. So it can actually create devices on the fly as it's parsing through the syslog. And it can also marry the syslog events back to those devices using DNS and from the NMISS events log. So it can help pull those things together. In most cases, Clients will start with escalations in NMISS. Once they get used to how escalations in NMISS work and build that out, and they start hitting kind of roadblocks and what they can do with events, then they'll start handling certain types of events in opEvents, and eventually turn off all of the escalation systems in NMISS and just do everything, all of your event escalations, your actions, your event handling in opEvents. So opEvents builds on and enhances NMISS's thresholding system. It does this by taking several different approaches. The first is, quite simply, it offers a whitelisting and blacklisting of events. So you can actually force what events will always be handled in the whitelisting event, in the whitelist. You can identify events that will never be processed in the blacklist. It'll handle event correlation, so you can take multiple individual events and roll them up into a synthetic master event, like a location outage, a group outage, a geographic outage. It handles event deduplication. So if you're being slammed with duplicate events, it'll deduplicate those and roll those all up into one event and simply say, this event has happened 20 times in the last X amount of time span. It'll handle event storms. So you have a regional power outage and the system's getting slammed with devices down. It'll handle event storms. It'll also handle event flap. So event flap is a little different from deduplication. Event flap is generally when an event is happening very, very quick in a very short amount of time. Devices going up and down and up and down and up and down. It'll identify that as a flap, and it'll actually roll it up into an event flap at that point. opEvents also supports the application of event actions or responses to events. And we're going to talk about that in a little detail. It supports a completely flexible escalation notification policy. In NMISS, you had those 10 predefined escalation levels. In opEvents, you can define as many escalation levels as you want, and they can be all at different periods of time. So you can create very, very flexible escalation policies there. And it also supports custom email templates per contact. So where NMISS only has one built-in email template, or it could be expanded by creating a custom notification, you can just create email templates in opEvents, assign those email templates to a contact, and then when that contact gets emailed or gets assigned to an escalation, NMISS will automatically use the template that's assigned to that person. So what does event processing look like in opEvents? So it'll first apply an archive list. So those are events that have to be stored out into something. Events that should always be archived. Then it'll apply a blacklist. Those again are events that should never be processed. Then a whitelist. Those are events that should always be processed. It'll correlate events into outages. It'll then deduplicate events. It'll determine the priority of events. It'll conduct any actions, and then it will start your escalations. Just some basic configuration files that you should be aware of. We're going to touch on these in a little more detail here in a minute. So first of all, event correlation. So how are correlations done? Correlations are all time-based. They're grouped as defined within the event. So for example, you might say within a 60-second window for events that all happen in the same group at the same location, roll it up into a customer location outage. So that then becomes a synthetic event, customer location outage. You can define a window of time, a minimum number of events for synthesis. You can inhibit correlation firing. There's all kinds of cool things you can do. Again, link at the bottom of the screen. And let's take a look at what event correlation looks like. So event correlations are handled in a file called EventRules.nmis. And so we're just going to look at correlation rule number 15 here. So this guy. And these all evaluate top to bottom based on the number that's assigned here. So you can see we have a name given to this one called customer outage. It's looking at the opportunity of up to 3 different events: node down, service down, SNMP down. So any combination of those 3 events happening within a 30-second window, and you have to have 5 of them. Now, you don't have to have 5 from 5 different devices, but you have to have 5 events. Again, any combination of 5 of those 3 events happening inside a 30-second window. So inhibiting allows you to inhibit the correlation firing for the defined time window. And what I mean by that is the system is going to look at these events and how long will it hold its breath before it determines if these things all happen within that time window. So it's an expansion of the window of time, and it's giving the system a little bit more moments to see if the device comes up or down. Because sometimes during a node down, for example, NMISS will go into a fast ping situation, and it'll continue to ping faster and faster, trying to see if that device goes up. Inhibit, rather than this firing at time 0, will give NMISS an extra 30-second window of opportunity to make sure that that device, that event rather, doesn't clear for that device. Count is how many minimum number of devices need to be matched within the window in order for the synthetic event to happen. Group by allows you to group this event by certain things. So for example, we want to know if any of these 3 events happen within a 30-second window to any individual customer. So we're grouping node.customer. So I don't care that I get 5 events with 2 from customer A, 1 from customer B, 1 from customer C, 1 from customer D. I want all 5 of these events to come from the same customer within a 30-second window. Enrich allows me to add additional information to the synthetic event that I'm creating. So in this example, if I find any of these 3 events, if I find 5, any combination of 5 of these 3 events in a 30-second window from the same customer, I'm going to set the priority to 8. I'm going to create a stateful event called customer outage, and the state of that event is down. Now, you'll notice in rule 16, I have a rule called customer up, and I'm looking at node up, service up, and SNMP up. It's grouping on customer. It's now a priority 2. Its stateful event is customer outage. So this event is going to clear rule 15. There are some additional rules that are covered on that web page. You can actually copy data from the event, copy first, copy previous, copy last. All of these different copy first pieces allow you to define settings from the original events that you want to copy to the synthetic event. I know that seems a little complex, and it is. We ship with several examples of these different pieces. I recommend you take a look at this. Take a look at the EventRules.ms file that ships. And again, make a list of what kind of matches make sense to you. You'll see, for example, that we have things like location outage and location up. We have a customer outage as a synthetic event. We have a group outage. So that's all grouped on node.group, and you have a group up event as well. You might even do a synthetic event of a synthetic event. So you might say, I want to create a mass outage, and my events might be a group outage, location outage, customer outage. And if I have 5 or more of any combination of those, then we want to create an other synthetic event from that called a mass outage, or everything's falling apart type situation. So good option for you there. All right, so that's how you define event correlation in opEvents. We also have event actions. So this is the concept that when something happens, when an event is being processed, you want to take some kind of a proactive response to it. Event actions are stored there's a section in the EventActions.nmis file called script. All of your actions are defined in the script section. You can call those scripts in policies and also in escalation rules. So let's take a look at what that looks like as well. So event actions, and let's scroll up to the script section. So you can see this is the script section. These are actions. So for example, I have an action called mtr node. And what it's going to do is it's going to run the mtr command. It's going to pass to that command the node.host name as the argument to that command, and it's going to save the output of that command. You'll see here we have one called trace route node. It sets the arguments for trace route. And you'll see that we have some static text here, max hops equal 20, but then we also have a variable here, node.host, and that'll be replaced inline by opEvents, and we're going to save the output of that. So let's take a look at what that actually looks like. I'm going to switch over to opEvents. We have here, this is the main dashboard in opEvents. We have events over the last 2 hours. And I'm just going to show, let's see the last 50 events. I'm going to scroll down through this. We see node flap, node down. All right, let's open this up to the last 4 hours. I'm looking for a specific node down that didn't get cycled into a flap, because events that are correlated into a flap do not execute actions. So here we have an SNMP down. So I'm going to click on this. Now we're going to go into the event details for this. So you'll see in the top left, we have things like the name of the node, the group, location, customer, business, service, host. These are all customizable. We have the details of the event itself. And then if you look down in the middle, the actions taken in the event, you can see that it was auto-acknowledged, and these are in the reverse order that they happen. 2 scripts were run, ping node and trace route node. So these were 2 event actions that were run. And the priority, 3 was added to the current priority. You can see the output from trace route node and from ping node down at the bottom of the screen. So the output for those, that's where we said save equals yes. The output from those commands was saved to this specific event. Now, anything that can be executed from a Linux command line, so a Perl script, a PHP script, a bash script, a command line like ping or traceroute, anything that can be executed from a Linux command line can be called as an action. So think about the applicability in your specific situation. The idea that maybe you have some homegrown software and it has a memory leak. And so when you see high memory usage on a server with a specific service, you might restart that service. You might restart or reboot that server. You might send a net notification to all users who are logged into that server that the server is going to be rebooted. So there's all kinds of things that you can do. It comes down to, from our workflow, the concept that if an engineer is responding in a known series of steps when something happens, then you should be able to document what those series of steps are, put that together as an NMISS action, as an opEvents action rather, and do that as a response to that event. So rather than having to wake an engineer up at 2 o'clock in the morning to restart a service that's gone down, the system should see, for example, that high memory usage on that service, restart the service, and if the high memory issue isn't resolved, restart the server, log all of that to the event, and still notify the technician, but maybe they don't have to wake up in the middle of the night. Maybe they can just respond to it in the morning when they come into work and see what's happened. So event actions, again, they're nothing but scripts. You can have there's all kinds of different ones you can do. The examples we ship with We ship with a good example here. You've got ping node, trace route, MTR, ping neighbor. So you're still executing a ping, but you're changing. You're sending different arguments, and you're sending the neighbor element to it rather than the host. You can also execute if you have opconfig, which is our configuration compliance system. If you have that installed, you can gather things like you can anything you can run from the CLI of a device, you can have opconfig do. And that's all we're doing here. So we're gathering information about BGPs. We're going to gather iOS top flow talkers, CPU routers, and it's just executing local commands inside opconfig, and opconfig is doing the work and then returning the results back to opEvents. You can gather information from Linux devices as well, Windows devices as well. And again, anything that you can execute from the command line, any kind of a program that you can run from the command line, you can do as a script. So event escalation happens a little differently in opEvents. The rules are fairly straightforward. Let's take a look at what some of those look like. And they're a combination of two things. The first is a policy, and policies are at the top of the event actions file. So for example, you can see, let's pick a simple one here. So number 10, we're saying for nodes with a role type equal to core, and event.event contains the word down, that's QR, is a search, right? So it's a regex command, actually. We're searching for anything like down inside event.event. We're going to add 3 to the priority. And that's where in here, you saw this priority. This was add 3 to the priority. That's where that came from. And then later, you can see that here's an example of doing it with distribution, but we're only doing it for priority 2. And then if I scroll down, you'll see that we have an example down here. Event.event includes SNMP down or node down, run script ping node, and script traceroute. And so you can string as many of these as long as you want. So for example, the next one down, you see we're setting priority to 8, running script.ping node, script.ping neighbor, script.troubleshoot BGP. So we're running lots of things here as well. These are all calling scripts. You can also, in addition to calling scripts, you can call escalations. And so escalations are defined at the bottom of the file in a section called escalate. And much like you would create contacts and then escalation windows in NMIS, you define those here. So for example, you have a weekday escalation policy, has the name weekday, and for devices with a priority greater than or equal to 0 on Monday through Friday, so weekdays from 9 a.m. to 1900, so 7 p.m. Again, that's server local time. And then these are your escalation windows. So you can define an escalation, multiple different escalation windows. So you'll see, for example, this one is 60, 900, 3600, 7200, but this one uses escalation windows of 60, 300, 1200, 2400, and 3600. And then you can call any script that you want. So for example, in this example, we're running the message XMP to operations, which is a script defined earlier, and we're running the script.ping node. So we're not even emailing anyone, we're just running some scripts. And then at time 300, we're running email operations, and then email operations pager, and these names are contact names. So lots and lots of things that can be done here. So again, escalations are stored in the escalate section of event actions. Escalations can be called from any section. So you can call an escalation from the policy or script sections. An escalation itself can call a policy action or a script. So escalations can actually execute scripts, logs, any action, or generate emails. The only thing an escalation policy can't do is call another escalation. Escalation timing is based on seconds, and it's from when the event that called the escalation started. So if I do a node down and I call an escalation based on a node down, the escalation is going to inherit the time, the starting time for when that event that called it occurred. Escalations are going to run while the event driving the policy rule is in effect. So as long as that event has not cleared or has not been acknowledged, the escalation will run. It's the same policy that NMISS does. And all rules in the if statement must evaluate as true to match the event. Email notifications are very similar to the way NMISS handles it. You have to set up global email parameters in the opcommon.nmis file. You have to build out your contacts.nmis file, or in many cases, again, it's sim-linked to the NMIS8 contacts.nmis file, although they can be separate. And then event emails.nmis defines which email templates to use for a particular contact. So each contact, you can have a general default, everybody uses one, and then you can break down and say this contact gets that email template. So if you have a contact that might be your help desk, you might have a custom template that you want to use for populating information that then gets emailed to maybe your help desk system that then parses it out and does something with it. You might have a custom email template for emailing something like PagerDuty, some kind of an online system that's going to do something with it, SMS, text messaging, automated phone calls, that kind of thing. All right, everyone. That concludes our webinar and our presentation for today. I'm going to turn off recording.